Hi, here we have the overall view of the testing setup with the three-phase machine. Now the system is monitoring three-phase voltages. As you can see now it's normal voltage on the serial monitor showing the same values. Now we go to the analog meter of the three-phase machine. It shows just nearly 35. Now the system is monitoring three-phase voltages. Whenever the voltage goes over 40, it will trip the relays and the buzzer will ring, the LED will light up, as you can see now. Now we will test the under voltage by decreasing the voltage below 30. As shown on the LCD, the system is still isolating the phase from the loads. And now if you go back to normal voltage, you will hear the relay connecting the supply to the loads. Here if you decrease the voltage below 30 again, the buzzer will ring, the relay will trigger to isolate the phase from the loads. Same will be true for over voltage, unless all three-phase voltages stay within the specified range. This is how the system monitors three-phase voltage and isolate the loads whenever a fault is detected in the supply. Here we'll be testing undercurrent and overcurrent. The system will be monitoring the three-phase supply currents. Whenever currents fall below 0.9 amps, the monitoring system will isolate the supply from the loads. Similarly, if the current goes above this upper threshold, which is about 1.25, overcurrent will be indicated and the supply will still be isolating the supply from the loads. And if you go back to normal current, the buzzer will stop ringing and the LED will be switched off, as well as the relay will connect the supply back to the loads. We're increasing the currents and decreasing the currents by controlling the supply voltage, as we can't actually decrease and increase the loads as we are testing. For sequence detection, the first attempt was with differential amplifiers. The practical test was not successful as the waveform did not behave as it did on simulations. Here is the simulation results, shows clearly the zero crossing for all three phases. Also, as shown here, the positive sequence was detected successfully on simulation, as well as the negative sequence was detected successfully. As a second attempt, optocouplers were used. The circuit was then tested practically to monitor the zero crossing of the input waveform, as shown in yellow, and below you can see the corresponding zero crossing pulses of the input waveform. However, due to time constraint of the project, it was impossible to test it with the real three-phase machine, three-phase supply. This will be a future work to test it in real life with a three-phase machine. As initial practical testing indicated, it's actually behaving as it should be, so there won't be any problem in testing it with the real phase machine.